you can hear a lot of Morse code going on. This is the receiver that I'm using to generate the sound, and the sound is coming out of these computer speakers here. The receiver can be tuned two ways. You can use a fine tuning. I'm going to adjust the volume, turn the volume down a little bit. The fine tuning can be adjusted here, this potentiometer. And coarse tuning can be adjusted here, this variable inductor. And I think there's a Morse code contest tonight, so the band is very full of Morse code. I'll turn the gain up here. And it's pretty obvious this is working. I'm going to go into a little bit on how it works. I'm going to disconnect the audio. It's a little bit better. Alright, so these are the main boards. We have the center board, which contains an SA612 direct conversion receiver in the form of a Gilbert cell mixer. So it takes RF from the input. This here is just two wires going to an antenna. And the antenna is just a spread of wires on my ceiling inside of my apartment. It's going into this microchip where it's mixing the RF from the antenna with the local oscillator. And the oscillator is mostly circuitry built into this chip. However, it uses some external circuitry to determine the frequency. That's a handful of capacitors and a variable inductor that I have here. I fine-tune frequency using a varactor diode. It's just a rectifier diode which I can push voltage against backwards to adjust capacitance by turning this potentiometer. Power supply is straightforward, LM7805, wow, it's hot, LM7805 voltage regulator, taking in 12 volts right now, but it will take in anything above about 7 volts, and it generates a stable 5 volts, which I'm sending into the board, and the input is just a variable inductor. It's actually a transformer. It's an IF transformer with a variable inductor in the center, so I turn the inductor until I hear audio. Actually, that might be something I can demonstrate now. Here's audio, and as I adjust the inductor, you can hear it gets quieter. So I twist it until it gets loud. That means that it's resonant at that frequency. So I adjust, turn it down a little bit. There you go. So that increases the selectivity at that frequency. This is the audio section here, and this is the input gain of the audio section. I'll unplug this again. The audio comes out of this chip, and it goes to these two connectors through a capacitor, and I limit it through this potentiometer to limit how much of it goes to this chip. This is a LM386. It's an amplifier all-in-one chip, and there's a little bit of supporting circuitry to try to stabilize the voltage to it and the output and that sort of thing. Nothing too fancy, and then it just outputs the audio directly to the speakers here. So with what we have here, we have everything we need to have a functional receiver that will give us full coverage over any amateur band, or at least the HF bands. And also note that the construction style is very open and has very large traces, especially here. Look how long these are. These are not optimal because a lot of interference can occur here, especially on the oscillator side. A lot of interference can get here and make the oscillator unstable or induce noise in the system. But this is really good for educational purposes. It makes it really easy to clamp to add resistors to, and that sort of thing. So all of these things are pluggable modules. I can unplug each one of these to work on it individually. So here's the audio section. There is positive power. And this is an example of one module. And if we want to add some functionality to the audio section, perhaps some filters, some notch filters, or a really narrow bandpass filter, we can work on just the audio module here. Somebody can handle that. The oscillator section has its own module. This is one that I came up with tonight using that variable inductor. However, I made one earlier today. This one works equally well. You can plug this in, and it uses a crystal to generate the frequency. So it's a very stable frequency, and there's a variable capacitor right there that I can use to shift the frequency slightly in one direction. So I hope with this little module system it provides a really easy way to develop some of the ideas and make it easy for students to build these and work on the individual components, and everyone can share and see what works well by snapping them into each other's boards. So this is a good example of a starting radio, and from here we can of course make it a little bit more elegant, but this is a good starting point. So we'll put it all back together, see how it goes. Actually, I'll try the crystal. I haven't tried that tonight. Slide it in. This is hard to do while holding the camera. Crystal, antenna. I think that's in the correct place. Audio board. I shouldn't have unplugged all of this. I'm sorry. Audio board, positive power. Plug the whole thing into the power supply. Now we have power. Plug in a speaker. And you can see with the crystal, it's working beautifully. I can probably adjust this if I need to for maximum volume. That looks good to me. Adjust the input gain. There you go. It's working really easily. And with this variable capacitor, I could probably adjust frequency. So there we go. We have a working radio receiver.